Hello everyone, myself Professor Pawar Didi from Nagesh Karisge Orchid College of Engineering and Technology Solapur. So today we'll see the topic electrical traction. So in this topic we'll see the different type of the electrical traction system, different type of the motors used for the traction system, different type of the engines used in our electrical system and or the in Indian Railway. So there are two types of the electrical traction, that are the mechanical traction system and our this electrical traction system. So we'll see the electrical traction system in our India. So let's start with the basic history of the Indian Railway. So, in a history of Indian Railway, we know that there is a different type of the engines are available in Indian Railway. So, working on a steam, diesel, battery, as well as the electrical. So, our motto, main motto, is see the more information, deep information regarding the electrical locomotives. Now, we know that the India having the 170 year of the history for the railway. Normally, in 18th century, first railway is introduced in India. So before that, we'll see the definition of electrical traction. What is electrical traction? A locomotion in which driving force is obtained from the electrical motor is called as the electrical traction. Exactly, whenever there is a movement of the motor, then because of the electrical supply, that is called as the electrical traction system. So normally in 1981, German engineer invented the electrical traction, and in 1925, Indian Railway introduced the electrical traction system with 1.5 kV DC between the Mumbai CST and Kurla. So from this we'll get the idea about our Indian electrical locomotive. So, how much voltage is used for the electrical traction? So, near about 1500 voltage DC and the 25 kV AC is used for the mainline. So, there is a requirement of the conversion of AC to DC, DC to AC from the substation. So, as per requirement, there are the utilization of the equipment. So we'll see the system of the electrical traction or the type of electrical traction system. So as per supply requirement or supply provision, there is a AC system, DC system, as well as the composite system, or we can say that condo system. In AC system, as per availability of the supply, there is a classification, that is a single phase and a three phase system. And in a composite system, the single phase, three phase system and single phase DC system is available. So we'll see the Indian Railway engine coding terminology. Ever you surprised that what are the types of the engines and what numbers and whatever that words are written on the engine? Never. So we'll get the idea after this. After watching this, we'll get the information regarding our Indian Railway coding terminology. So Indian Railway coding terminology consisting of the five main components, that is gauge, power, load, series, and suffix. So gauge is broadly classified as the normal gauge, meter gauge, standard gauge, and the broad gauge. But normally we are using standard gauge and the normal gauge right now, and in a meter gauge. Broad gauge has been used in a previous time when there was a engine running on a steam. Now, depending on the power, this also coding terminology is given, that is the AC power, DC power, or battery power, or the diesel. So these are the some fuel which are used to run this our locomotive. So depending on load, the more we can classify the train, that is a mix passenger, goods, and shipping. Over along this, there is a one multiple unit that is used for to shift from one side to another side train. Now, series has been given by our company or the manufacturer. That is one of the important parts of this coding terminology, that is the series that is given by the our manufacturer, like as a where we are having BHEL as a BHEL as a manufacturer, and some suffix are the given by from the some variations. So we'll see some example from that, will clear the idea what type of the number has been given to our railway, Indian Railway, and how the number has been given to our railway. So basically from we know that this number and whatever this words are given to the our in railway is given from this gauge, power, load, series, and the suffix. So we'll say take one example. If this type of the number is written on the railway, that is WDP3A, this type of the some word is given on a railway. So how we can identify which type of the railway is this and how these number are given? So from this we know that a gauge, power, and whatever that consumption and the series given, we'll see here. So the W stands for the wide gauge, D stands for the diesel power, P stands for the passenger train, and 3A is given by the company series number. So this is the example. So hope so from this will clear the idea how the numbering system is given to our Indian Railway. So normally system voltage, how are which type from the we have seen the types of our electrical traction system, that is having the single phase, three phase, AC system, DC system, and the composite system. So in a system voltage we'll see the DC system. So normally DC system utilizes 600 voltage to 3000 voltage. Normally the area has been divided into two parts, suburban area and the main service area. So for suburban area, DC voltage is supplied up to the 600 volt to 750 volt, and in main service area the voltage is given 1500 volt to 3000 volt. Now here in a DC system, DC series motor has been used, or the tramway or trolley has been used. So from this DC series motor is energized by our DC supply voltage, and whenever this DC motor runs, then our whatever the wheel of our train is get rotated. Now there are is important thing that the current collection, that is current collector, the how the current can be collected by this train. So this train is current is collected by the pantograph or the current collection, we call as a third rail type or the overhead conductor. Now here driving power is used from obtained from the substation. Normally substations are placed in after some time, that is near about after 5 to 10 kilometers. That is from that this power is given to the pole and the from overhead conductor, and then from overhead conductor the whatever the supply is get conducted or connected by this DC motor. Now next one is a single phase AC system. So this is usual and identified system, that is the use 15 to 25 kV voltage. After this voltage has been stepped down, so near about this step down up to the 300 voltage. Now here the single phase three phase AC series motor or single phase AC series motor is used. Normally we can use DC series motor, but because of the AC system we have to use AC motor. Now here supply of the voltage is near about the 15 to 25 kV voltage, and that is a tremendous voltage. So it is necessary to step down this voltage, and this voltage is stepped down by the step down transformer in up to the 300 volt. Now the spacing of the substation is near about the 50 to 80 kilometers, and the frequency is reduced to the 25 hertz. So here the voltage is also reduced, but the frequency is also reduced. Reason for the reducing the frequency is that it reduces the reactance and hence the voltage drop. As the voltage drop is decreases, so there is improvement in a system occurs. So this is the single phase AC system. Three phase AC system. Here in three phase AC system, voltage is more than single phase, and the DC system, that is 3.3 to 3.6 kV voltage. Here three phase induction motor is used up to the 25 hours. Similarly we have to step down the voltage as well as the step down the frequency. So frequency is obtained up to the 25 hertz. Now here the distribution system consisting of two overhead track rail and receives power from the transformer. Similarly the current collection can be done from the overhead lines, and but here there are two overhead lines, that can be current can be collected from overhead system. Here the voltage and frequency is stepped down, and normally this three phase AC system is employed in a hilly area where we need a high starting torque and the high output power. So one disadvantage of the three phase AC system is the complication in a crossing. Obviously there is consisting of the two overhead lines, so it is will be some complications while the crossings. So we'll see the block diagram of the AC locomotives. Thank you very much.